Alright, Newton's first law. Every object continues in a state of rest or of motion in a straight line at a constant speed, unless it is compelled to change that by the state of forces exerted upon it. So what we did to demonstrate Newton's first law was we rolled a ball forward on the grass, and the friction of the grass slowed it down and made it go to a stop, which demonstrates Newton's first law.
We placed an index card over the cup and a candle over the index card. When we flicked the index card, the candle went into the cup because the candle was originally at rest, stated by Newton's first law. In our textbook, on page 60 of Newton's second law, we learned that the acceleration produced by a net force on an object is directly proportional to the magnitude of the net force, is in the same direction as the net force, and is inversely proportional to the mass of the object.
I dropped two different cups, and this exhibited Newton's second law. One cup had greater weight and greater inertia, so basically what happened was the greater weight and inertia offset it, so the cups actually fell and hit the ground at the same exact time.
We pushed a swing that didn't have anyone on it, and it swung fairly fast, but when I sat on it, it added more mass, which added more inertia to it, so the swing swung a lot slower.
On page 75 of your textbook, Newton's third law states, whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object.
To demonstrate Newton's third law, action-reaction pairs, I threw a ball against a shed. The ball exerted a force on the shed, and the shed exerted a force back on it, so it bounced back to me.
When I was walking, my feet were pushing against the ground. The ground in turn pushed against my feet, which was an action-reaction force, as stated in law number 3.
This project included Shruthie Gnaneswaran, Janessa Cimfl, and Hannah Balducci. A robust credit voice by Anthony Balducci.